This UGREEN NAS is a beast when it comes to specs, but can it run Windows? Or can I install Proxmox maybe directly on this device? The surprising answer to both of those questions is yes, you can. I will show you how to run other operating systems on this NAS without touching the current UGOS, which is an operating system installed by UGREEN. And what that means is that you can revert back to UGOS anytime you want, which means you can run basically multiple operating systems on this device. I will also show you how to run Iperf test to check the transfer speed between this NAS and other devices you might have at home, and we will talk about RAID arrays and a bit more. Maybe let me put it back, because currently with just 3 hard drives installed, this NAS already weighs more than 5 kilograms. That's a bit better. And as I mentioned, you can run different operating systems, and not only Windows or Proxmox. You can also run TrueNAS or Unraid or pretty much anything you want. Because although this device comes packaged as a network-attached storage, you can really treat it as one more PC at home, but one that you can equip with a lot of storage. Because in this fairly compact aluminum case, you will find 3 SSD slots and 4 hard drive slots. And I know some of you will say, Marek, hey, there are only 2 SSD slots listed on the device spec, not 3. But the fact is, you can pack up to 4 30 terabytes hard drives and officially 2 8 terabytes SSD drives, but the fact is that there is a third SSD drive with the UGREEN operating system installed. It's 128 gig SSD drive, or NVMe I should say, which you can also replace if you want to. I am not going to do that. We will leave this system SSD where it is, but I will show you step by step how to run other operating systems and how you can revert that change back to the original operating system anytime you want. This particular model, DXP4800 Plus, is slightly different than DXP4800, with no plus I mean, mainly because it has copper 10 gigabits per second Ethernet connection. In fact, there are 2 ports. One of them is 2.5 gig and the other one is that 10 gigabits per second port. That 10 gigabits per second port might be perfect for media creators that need very high transfer speeds and they read and write a lot of data every single day. I think it's worth to mention that this is a sponsored video, but sponsored in this case only means that UGREEN provided this device so I can test it with you today. I have no idea or any influence over what and how I want to test it, and installing Windows on their NAS is probably not exactly what they had in mind when they said testing, but I thought it might be quite interesting to see what's possible. Let's start from the beginning though. When the device arrived, first thing that surprised me was the packaging, and I mean a lot of packaging. This video starts with one box already removed, so this is the second box, and then when you open it, there is yet another box, the black box. I have to admit the quality is great already, not about the device itself, but also the box. It feels and looks like a quality product. And this inside we've got the NAS itself, of course. We've got yet another box with the power adapters, some screws, even screwdriver, a lot of stuff. There is also magnetic mesh, and that's the box itself. And I have to say again that it really feels like a premium product. We've got 4 bays in front of it. It's super easy to install hard drives, which I will show you shortly. And in the back you can attach that magnetic UGREEN mesh. It makes it very easy to clean it periodically. These are the remaining bits. You get 2 Ethernet cables, power adapter, warranty, manual, as I said, some screws and screwdriver, and you also get thermal pads for internal SSD drives as well, which we will use later on. Initially, for the testing purposes, I installed only 2 hard drives. They are 4TB Seagate Iron Wolf, and I didn't insert any SSD drives. To install the hard drive, you don't need any tools, you just need a working finger. You just press the button at the bottom of the bay, you pull it out. There is another push button at the bottom of that bay. It will let you place the hard drive inside of that bay, and you just align it with sticking out pins inside of that bay. That's all it is. The drive will not go anywhere, it's already fixed, and you just slide it back in. You will hear a little click. That means it's all done, and I will do the same for the other drive as well. Again, take it out, push, place the drive, slide it in, and that's it. It's worth to mention that you can also use 2.5-inch drives if you want. And the screws and screwdriver is already provided. And to fit 2.5-inch drive, You have to first remove a little screw or pin, and that will let you align the holes at the bottom of the drive, because that's how it's supposed to be fixed, and then you should be able to slide it in just like the other hard drives. That's all it is. But I'm not going to use it. I just wanted to show you that it is possible to use 2.5-inch drives. I'm not going to use any NVMe drives yet, but let's have a look what's inside. At the bottom you have that little plate. There are just 2 screws, and it gives you access to RAM memory and 2 M2 slots for PCIe Gen 4x4 SSD drives. And if you wonder, yes, RAM is also upgradable. It's currently 8 GB there, but you can upgrade it up to 64 GB because it can take up to 2 32 GB memory modules. These are the ports at the back of the device. We've got one 10 gigabit per second Ethernet slot, copper one, which is very important to mention as well, because copper is much cheaper than SFP slot. That's another advantage of this device. The other Ethernet port is 2.5 gig. We also have some USB ports, and there is HDMI port, which is also interesting because it lets you watch films directly from this NAS over HDMI, although that software is shown as a beta version. But we will use that HDMI anyways, because we will need to access BIOS. That will come very handy then. In front we've got power button, we've got SD card slot as well, USB-C and USB 3.2. They are both 10 gigabits per second ports. Let's power it on then and have a look what's going on here. You have to give it a minute or two before it boots up properly. As per manual, you have to have it connected to your local network, and then from any device in local network you should be able to access this device. I just wanted to be sure that everything is fine, so I logged on to my router and I could indeed see that this device is now seen on my network. To connect to it, you just type find.ugreennas.com and that's it. You will be able to select and to connect to this device. Then you go through simple setup process. You can choose device name, you accept some user agreements, blah blah, and you create as well account name and the password. The account name cannot be admin, as you can see, because it already exists as a system account. I chose Marek instead then, and that's basically it. You can also configure UGREENLink, it's called. It's something similar to Synology Quick Connect. If you want, you can configure it here, but I might do it later on. Then you just leave it for a few minutes. It will do whatever it has to do. Then there is a little guide that will show you what is where and how to use it. That's basically it. Your NAS is up and ready. But you have to configure the storage, because you have to make some decisions here. You choose first which hard drives you want to use to create the storage pool, and because I only have 2, I will have limited options here. As you can see, RAID 1 is recommended one. That's what this green rec means. But RAID 5 is not available, because for RAID 5 you need 3 or more hard drives. And I will configure RAID 5 later on, but if you wonder what's the difference between, for example, RAID 0 and RAID 1, RAID 1 is recommended simply because it provides data protection. But if you check the storage size, you have 2 3.6 terabytes drives, but if you choose RAID 1, the total storage is still just 3.6 terabytes. That's because when you choose RAID 1, that basically means you save the same data to both hard drives. And then when one of these hard drives fails, you do not lose any data because your data is also on the other drive. And then you can also replace the faulty hard drive, and then the RAID array will rebuild itself, will simply copy the data from the working hard drive back to the new hard drive, and this way your data is secure. It can survive a failure of basically of half of your storage. I have here just 2 hard drives, so basically it can survive a failure of 1 hard drive. But I will choose RAID 0. RAID 0 is not recommended, but it has 2 advantages. First advantage, I have full size of my drives available. As you can see, it's 7.2 terabytes available out of 7.2 terabytes currently in the system. And I will also have better read and write speeds, because when data reaches the NAS, it will be then split between 2 of my hard drives. Some data will go to one drive and some data will go to the other drive. And also when I read the data from the hard drives, I can read basically from both hard drives at the same time, because some parts of my data will be on one drive and some part of the data will be on the other drive. And the NAS can pull that data at the same time. But the big disadvantage is that even if I lose one of my hard drives, I will lose all the data, because for RAID 0 I need all of the hard drives in my system healthy. If one fails, all my data is gone. Then you have to assign file system. You can choose between ext4 and BetterFS. ext4 is older, but it's also super stable. It's good enough for my use case. And then you just say create. So we've got storage pool and volume created. It takes just a moment, but then it will take quite a while to optimize that volume. That's for RAID 0, but for RAID 5, for RAID 0 it will take around half an hour, that optimization process. But for RAID 5 it might take up to 6 hours or even more for 4 terabytes drives. But once that's done, you can create a shared folder or you can create personal folder. Personal is per user, let's say, and shared folder is the one that you want to share with your team, with your family, whoever. Personal will be the same as your user, current, and the shared you can call it whatever you want. I will name it UGREEN shared maybe. And then for shared folder, you can assign permissions per user. I have only one user, it's only Marek here. But if you have multiple users, you can say which user can read, which user can write, or which user should have access denied. It's a very easy process to follow. If you go to control panel, file service, you can enable Samba or NFS or FTP. I will go with Samba because it will work with Windows as well. And here at the bottom it will also show you how you can connect to this shared folder. It mentions Windows and Mac only, but for Linux it basically will be the same as for Mac. In my case I will use Ubuntu, which means I can use that instruction for Mac Finder, because that's the same. And this is my Ubuntu. And how do I connect to it? I just click that other locations, I paste that link, which is for protocol Samba, the name of the device is UGREENNAS, and then after that I have to add the shared folder I want to connect to. Currently I have only one, and it's called UGREEN shared. Just click connect, I connect as user Marek and the password that I've just created on my NAS. Currently it's just a recycling bin, but I can for example create new folder and I can call it whatever. Now if we go back and if we go to control panel and terminal, I want to also enable SSH. That's optional, but I like having SSH access. SSH gives you much greater control and you can see, let's say, what happens in the background, alright? Because this is just user interface, but I want to see what's going on in the background. Note that the port number can be changed. It doesn't have to be 22, but then you have to remember that you have SSH running on different port. And I don't shut it down, I want this to be permanently enabled. That's why I choose never. And in advanced settings, just to keep it secure, I will say that only people from local network can access this device. That means I can go back now to my, because this is terminal from Ubuntu, which is another server I have in my local network. And from that server, from Ubuntu server, I can now SSH as user Marek to my NAS using either its name or its IP address. IP address is here, 192.168.191, so I can just copy paste it. Again the password, that's it, I am on my NAS, connected via SSH. I can run for example cat etc os release command, that will show me that this NAS is running on Debian version 12, Bookworm. If I run lsblk, which means list block devices, I can see both my hard drives and I can also see that operating system NVMe drive, which is 128 gig in size. And I can see the logical volume created. Logical volume includes both of my hard drives and it's 7.2 terabyte in size in total. Let's run some tests now, alright? On my Ubuntu server I can run dd command. I can choose interface device random, output file I will call it 10GB test.txt, and count in block size. That basically will create a 10GB file for testing purposes. And I will place it in temp folder maybe. Now let's just double check. Yes, it's there. It's 10 gig in size indeed. And to run a basic speed test, I can run simply scp command, which utilizes SSH connection between my Ubuntu server and my NAS. I say then scp tmp 10 gig test file that I've just created, and I want to move it to user Marek at IP address of my NAS, and I want to place it in the shared folder. And the shared folder is on volume 1 in UGREEN shared folder. And I called it crap, so let's place it in crap folder. And maybe I will add time command as well. That will simply measure the time it took to copy this file from Ubuntu to NAS. That transfer rate should already tell you something, and it basically means my network is just 1 gigabit per second network, and I'm fully utilizing it right now, because 111 megabytes is roughly the maximum for 1 gigabit per second network. I will not be able to max out the internal transfer of hard drives because I'm limited by my network. But we can see this file indeed was transferred, and what we can do next, we can do it the opposite way around. I can SCP again, but this time from NAS to my Ubuntu server. But that's interesting. I noticed when going from NAS to my server, I can only get 38 megabytes per second roughly. And I wanted to know what is the reason behind it, because I should get the maximum throughput really. 1 gigabit per second should be download and upload between those two devices. And Iperf is a great tool that you can use as well, not only for NAS, but for any device really that supports Iperf. And Iperf is available for Windows, for macOS, for Ubuntu, any other Linux distribution probably. And the first thing I checked, if I have Iperf installed on my Ubuntu. Looks like I don't, because Iperf is for Iperf version 2 and Iperf 3 is for Iperf version 3. My Ubuntu tells me that it's not found but can be installed with blah blah. But before I install anything, I want to go back to my NAS and check if the NAS has the Iperf already installed. And while Iperf version 2 is not installed, I have Iperf version 3 on my NAS, which means it's better for me to only install Iperf version 3 on my Ubuntu. Now on my NAS, I'm still SSH'd to my NAS, yes, I can run Iperf-S command, which creates Iperf server. Basically my NAS will wait for incoming traffic or for any other device simply to contact it on that port. And on my Ubuntu, I can run Iperf3-C, which is for client. Remember, UGREEN is our server, so this Ubuntu will be our client, and I ask my Ubuntu to connect to 192.168.1.91, which is IP address of my UGREEN NAS. And I just press enter, and that tests the networking between those devices. It doesn't care about hard drives, it doesn't care about NVMe drives or any other drives. It just tests the networking. And the only bottleneck here can be either my network or CPU on any of those devices. And I know CPU will be fine. The NAS has 5-core CPU, which includes 1 performance core and 4 efficiency cores. And my Ubuntu runs on 4 performance cores, so I'm fine. But I'm also maxing out this connection. 960 megabits is basically the max for 1 gigabit per second networking. And that's fine, but the problem was in the other direction. And the Iperf has a command that you can run. It's --reverse. It will tell the server to generate the traffic instead and send it towards the client. That's a very easy way to test the traffic in both directions. And now I can clearly see that something weird is going on, because I get anything from 200 megabits, or even 150, sorry, up to 600 megabits. But if you think I'm going to troubleshoot anything, no. I'm pretty sure I know what the problem is my 8-pound TP-Link switch. Now my only problem is if I should go for 2.5 gig new switch, or shall I go and spend an extra money for 10 gigabit switch. If you wanted to run similar test but in user interface, you could also just connect to the Samba share, like this UGREEN shared folder, and just drag and drop that file, either that 10 gigabyte test file or any other file you want, and the transfer speed should be shown anyways. As you can see here, it's even lower than it was when using CLI. It shows around 23 megabytes per second. That's alternative, but I like using CLI because I can use, for example, that time option, which will show me the exact time it took to transfer the file. But let's now talk about those other operating systems. How do I run different operating system on my NAS, not touching that UGOS? I need a pen drive and a different device like laptop, PC, or any other device that is able to create a bootable USB drive for me. I will just use my laptop, I will just slide in the USB stick, and what I do next is the Proxmox. I want to install Proxmox. I go to the official website and I download Proxmox ISO installer. You just click download, wait a few seconds, and once the ISO is ready, you need a program that is able to create bootable USB drives. I will use Balena Etcher, for example. But there is Rufus, there are many ways you can create bootable USB drives. In this example, I just run Balena Etcher. You just click on it, you say flash from drive, you pick the ISO you have just downloaded, you say open, you select target, and the target is that USB drive I just inserted, the SanDisk USB drive, and you just say flash. You might get some pop-up windows, because Balena Etcher will create like file systems, etc. You can just close them, you just wait for the flashing process to complete. The Balena Etcher process should be uninterrupted. Even if you close these windows, it shouldn't affect the USB creation process. After the flashing, there is a validating process. It doesn't take long. And you might get some pop-up windows again, but you should also get flash complete message. That's at this point you remove the USB drive, because that's all you need here. Now, if your NAS is still up and running, you just shut it down. And you can use hard drives as well for this process. You can install operating system on the hard drive, but I've got a small 256GB NVMe SSD drive that I will use for this purpose. I will install just this one drive, SSD drive, and I will install Proxmox on this little SSD. That's it. But next, you have to connect some things to this NAS. First, you need the HDMI cable. That's what I said. That's what we need to connect to BIOS. Then you have to insert that USB stick we just flashed. You have to insert it into one of the USB ports. You need as well wired keyboard and connection to your LAN. What I forgot about is also a wired mouse. I connected it later on. I'm not sure if it's necessary, but for Proxmox installation process, it's better to have a mouse connected. You start your NAS, and then as soon as you can, you press Ctrl and F12 buttons. And you keep pressing that Ctrl and F12 buttons until you get that little blue window. This is where you can enter the BIOS settings. By default, it's set to Debian. Debian is basically, as you could see, that UGOS is a Debian-based system, and we want to change it. We want to boot this device from the USB drive, but we also want to include that SSD drive we just installed, that 256GB that I've just placed, because that's going to be my drive for my Proxmox, yes? So I say enter setup, and setup means BIOS. I go to boot section, and you can see boot options here. Surprisingly, first one is hard disk chosen, second one is Debian here. As a boot option number 1, I want to choose my SanDisk USB drive. Remember, SanDisk is the USB where we used Balena Etcher. It includes Proxmox installer. But the next one, we want to have our NVMe drive. You have those M2 key M1 boot options. You can see 2 of them are disabled. We want to enable them both. I need one only, because I put the SSD in one slot, but I don't know which one it is. So I will enable both of them, just to make sure that I am able to boot from one of those SSDs. And once I get them enabled, I go to NVMe drive BBS priorities at the bottom. And here I choose my SSD 250GB NVMe drive as a first one, boot option number 1. And you may ask why? Because once my Proxmox is installed on my NVMe 250GB, I want to boot that Proxmox. But then anytime I want to revert this situation, I just change it here. I would choose my Debian as boot option number 1, and this would actually boot my UGOS, the UGREEN operating system. Hope that makes sense. Because we are now playing with Proxmox though, let's leave it as it is. 250GB, currently empty SSD, will be my boot option number 1. That's all sorted. Here on the main page, we've got boot option 1, SanDisk, our USB drive. Boot option 2 is now shown correctly as NVMe 250GB. You save and exit, and just wait. The NAS should now read the information from the USB stick first. And it does. It can see Proxmox installer. You just click the first option, selected by default, and the process will start. And the Proxmox installation process isn't long. You agree to license agreement, blah blah. And here is pretty important portion. At the bottom, you have to make sure you choose correct target hard disk. You don't want to overwrite your current UGOS, yes? The UGREEN operating system is on this 128GB first here on this list, is the first SSD drive. We want to install Proxmox on 250GB one. But you can also see, if you wanted, you can install it on the hard drives as well. 3.64TB these two are hard drives. But I will choose my 250 gig, but it's very important moment. Because if you choose wrong one, you will overwrite all data. But before I had the chance to choose it properly, everything just went black. And I was like, what the heck, what is going on? I quickly started pressing Ctrl and F12 again, because I knew it has to be something in BIOS, still incorrectly configured. And after a quick peek, I found this watchdog control. And this watchdog control, what it does, if you don't start running your operating system in 3 minutes, it will simply reboot again. So I was basically halfway installing my Proxmox, and I was just kicked out by this watchdog control process. We want to have it disabled then, and only once I disabled it, you will save and exit again. Unfortunately, I had to start the process again of Proxmox installation. And again, Proxmox v graphical as the first option anyways. And we are at the same point again, where you have to choose the correct hard drive. Remember to choose the blank one, not the one with UGOS already installed. You choose the password. There are just very simple steps you have to follow. Choose the email, the IP address you can leave, but only remember to untick that automatically reboot, alright? Because you want to remove the USB drive before the next reboot of this process. You don't want to boot from USB again. You now will want to boot from your NVMe drive with Proxmox already there. Now it says installation successful. It will also tell you how to log on to the device. It's basically the same IP address that we used to have for UGREEN 192.168.191, but the port 8006 that will have to be added. Now that's what I said. We remove the USB drive with the installer, that's SanDisk, and now we click reboot in the bottom right corner. And now you just give it a while. You should have a blank screen saying PVE login or something like that. And that means you can now disconnect everything because your Proxmox already works. You don't need even HDMI cable or anything. You can simply go to any other device and connect to your Proxmox over your network. You just go to HTTPS 192.168.191 on port 8006. And that's it. That's our Proxmox. And you can see we've got all the hard drives and everything available here as well. If you go to disks on PVE, that's basically it. You can now upgrade your packages, you can create ZFS pools, anything you want to do on your Proxmox, or run other operating systems on top of Proxmox, because that's the hypervisor, yes? But that's basically a process completed for Proxmox. Let's say not only Proxmox, because it will be similar for any Linux-based operating system. What about Windows then? What if you want to run Windows on this UGREEN NAS? And the main difference in the process is just how you create that bootable USB drive, to be honest. Let's just search for something like Windows 11 bootable USB, and you have that create installation media for Windows. That's what we can use. You can find Windows 10 and Windows 11. Fortunately, UGREEN NAS already has that TPM module, so we can easily install Windows 11, so let's go for that one. And here you have to create a Windows 11 installation media. That will download a small tool called Media Creation Tool. That's what you want to click, and it will open another pop-up window that will let you create that USB drive. You can use either previous USB drive with Proxmox, or I used another USB drive, it's a Kingston USB drive. And with that one inserted, you just follow the steps. Just make sure you select correct USB flash drive, if you have multiple, for example, inserted, but I have just one. And now the process will start, it will download the Windows. That's the main difference, to be honest. We don't use Balena Etcher or Rufus, we simply use that Windows Media Creation Tool. That process might take a while. Let me just fast forward it then. When it says the flash drive is ready, you just unmount it and you insert it into your NAS, just like the previous one. You shouldn't even need to change anything in BIOS this time. It should boot from the USB drive anyways. As you can see, it's now Kingston Data Traveler, and the Proxmox is still on that 250 gig NVMe drive, but we will now overwrite it with this Windows installer. In case it doesn't boot from USB, you can enter the BIOS and change the settings for boot option number 1 to be this USB pen drive. And then you just follow standard Windows installation process, to be honest. You will see disk 2 is my 250 gig, currently with Proxmox, and it has multiple partitions. So what I will do, I will first remove all those partitions, so I only have one disk 2 with unallocated space. Just make sure you do it on correct drive. For me, I have only one 250 gig SSD drive. So what I will do, I will delete all the partitions for disk number 2, and once I have disk 2 unallocated space, just one entry, I will choose it and I say create partition. I will just apply, and now I can install my Windows operating system on this SSD drive. Windows will create its own partitions anyways, but they will be now Windows partitions, not Proxmox partitions, if that makes sense. And the Windows installer will start. This process again takes quite a while. I noticed Windows 11, it takes much longer for Windows 11 than it did even for Windows 10 to get installed, but I will fast forward this process again, so you don't have to just stare on the screen. And everything was fine, you know, standard process, blah blah blah, until I reached this point. The problem was Windows could not find any drivers for current network interfaces. And my problem was I didn't know what these interfaces actually are. What I had to do, I had to stop the installation process, I had to go back to BIOS, I had to change that NVMe booting sequence so it boots from the UGOS, just to be able to SSH to this UGOS and run lspci command, and I also say grep Ethernet. That means it will only display my current network interfaces. And you can see there are two network interfaces. The 10 gigabit per second is Aquentia, I don't know what it's pronounced, but the other one is Intel Corporation Ethernet controller, and it's I226-V. It's pretty popular one, and it's that second 2.5 gig interface. I thought it might be easier for me to find that the drivers for Windows for that controller, so I simply searched the internet for I226-V Windows drivers. And I found them here, directly on intel.com, Intel Network Adapter Driver for Microsoft Windows 11. So I had to download them, put them on the USB stick. I actually placed them on the same USB stick that a Windows installer is in, but you can use separate USB stick, it doesn't really matter. And I had to then restart the process again, the installation process I mean. But fortunately Windows kind of remembered the previous steps. It went straight for the part where you have to choose the language for the operating system. And now I can click that install driver button and I can point the installer to the folder with the downloaded network driver for Windows 11. It was called wired driver 30.3, something like that. And now I can point the installer to that folder, so it should find the correct drivers. Now it obtained the address from my DHCP server, you can see it connected, which also means we can progress the installation process further. And now we just have to wait again. No more surprises, and maybe I will place the names of those controllers again. So if you want to use that 10 gigabit per second interface, let's say, then you know what drivers to download as well. That's it, job done. Windows has been installed, and if we check Device Manager, for example, we can see its name, UGREEN DXP, we can see all the hard drives, and we can also see those network adapters now. And when you provide the network driver for one of the controllers, Windows figured out where is the driver for the other controller, called Marvel AQ-Sion, whatever it is. You can see there are some devices where the drivers were not found automatically, but what you can do in that situation, you can right-click on it, you go to Properties, Details, you search for hardware IDs, and then you can Google for that long string. This is like hardware identifier for this device, and you can Google simply what it is and how to download the drivers. And we can also see the processor, which is Intel Pentium Gold 8505. You can also go to Computer Management, to Disk Management, and you can see here all hard drives, all SSD drives, and even that USB stick. But that's basically it. That's your Windows installed, ready to use. Now there is one more thing I wanted to show you. It's how to install another drive and change the RAID array from RAID 0 that I have currently configured to RAID 5. Plus I also have two SSD drives that I will use as a cache. It's a read-write cache that speeds up the transfer. So again, I just install the hard drive, just like the other two, slide it in, and now I can remove the previous SSD drive with currently Windows on it. And basically, if you remove this SSD drive and if you remove the USB drive, then the system should automatically boot from UGOS anyways, because there is no other drive that this NAS can boot from. So you should be fine again, even without changing anything in BIOS. But if you want to change the sequence, you can also change it and make the UGOS first. bootable option. For the NVMe drives, you will find a very thick thermal pads that you can attach to your SSD drives. They come together with the NAS and they are thick enough to touch this metal plate that we are going to screw back in. This is the plate I'm talking about. Those thermal pads should touch this metal plate. And now your NAS should boot the UGOS, and you can see the drives already, and it says that 3 of them are unused. And because I have already RAID 0 configured, I don't think there is another option than delete the entire storage pool if you want to change the RAID array. But that also means you will lose all the data, so you have to move it before you start this process. Fortunately for me, I don't have any data on it yet, so I can simply delete it because I want to reconfigure it to RAID 5. And now, with no storage pool, I can create new storage pool with that third hard drive included. As you can see now, when I select 2, there is no RAID 5, I mean it's grayed out, but when I add this third hard drive, I should get the option to choose RAID 5, and I do have that choice. That's because it says RAID 5 requires at least 3 drives. But notice that for the user, it will still be just 7.2 terabytes available. That's because this third drive will be used for so-called parity. I mean, it's a bit complicated process, but basically RAID 5 allows you to lose one drive, but you will not lose any data. And the RAID 5 should be pretty fast, the speed should be close to RAID 0. So it's something like you could think of something between RAID 0 and RAID 1. But you will lose the capacity of one drive in your pool. So because I have 3 drives, I will have capacity of 2 drives, and if I had 4 drives, I would have total capacity available for user of 3 drives. Hope that makes sense. You basically lose one drive for that protection mechanism. But except of that, the process is the same. You just choose your file system, you just say create, but as I already mentioned, the process of optimization will be much longer here. For me it took 6 hours, but it might take even more if you have hard drives of even larger capacity. But that optimization can run in the background. Let's add this cache in the meantime that will contain 2 of the NVMe drives I've installed as well. For that, I will go to one of those drives, I will say use, and I will say create SSD cache. And you have to create storage pool as well, and then you specify the volume and the cache mode. If you want read-write cache, you need 2 SSDs, because with one SSD you can have read-only cache. But if you need read-write, it says at least 2 SSDs are required to create. And I have 2 SSDs, so I can create read-write cache. And I just say next. If you have anything on those SSDs, you will lose the data, so make sure that you have nothing important on those SSD drives. Because mine are new anyways, I can just go ahead and accept that. And then you have to choose RAID 1 for this read-write storage pool. The RAID 1 is for the SSDs, yes? It's not for hard drives. It's like the special protection for this caching mechanism. And now you can choose both of your SSD drives. And capacity, I will choose full capacity, 916.3 in my case. And I just say apply, we have to format them as well. And that's it. That's how you create a cache for your storage. And when we go back to storage pool, we can see the optimization process still runs, but now we have also that SSD cache available for this volume. And we can see estimated time remaining for the optimization and syncing is 5 hours 56 minutes. And that is the time that indeed it took to complete this process. And I think that's all I wanted to show you today, so I hope you liked it and I hope to see you next time. Marek.